Bismillahirrahmanirrahim. Starting with the greatest name of Almighty Allah, whose benevolence is everlasting and whose blessings are uncountable indeed. Chemistrians, Assalamu alaikum. I warmly welcome all of you to an informative topic assigned by our respected Professor Dr. Hammad Majeed. Myself, Kinza Shafiq, and today we are going to discuss a beautiful chemistry of an amino acid called L-Histidine. The word itself is very interesting and mesmerizing. Just look at it. L-Histidine means lovely history. Starting with the contents, we have to discuss its introduction, structure, physical and chemical properties, then the chemical reactions it possesses, its functions, disorders due to its high and low concentrations, precautions, its applications in daily life, conclusion with some references. Okay, starting with the introduction. L-Histidine. What is it? It is basically a proteinogenic amino acid. Proteinogenic means the amino acids which are used to make the proteins. L-Histidine is basically an essential amino acid. Keep in mind that amino acids occurring in nature are of two types: essential amino acids and the non-essential amino acids. Non-essential amino acids are those which are naturally synthesized in our body, while the essential amino acids are those which our body is unable to make. So L-Histidine is one of the essential amino acids. As our body is unable to make it, so we have to take it through our diet. Its main function is for growth and tissue repair. Now you would all know the basic concept of amino acids. Before starting the L-Histidine, I want to give you the basic concept of amino acids. Normally, our bodies break down the protein foods like meat, fish into amino acids. Our food basically contains carbohydrates, proteins, lipids, water, salts, and many such things. But we are just talking about specifically the amino acids. When we take protein foods, our body breaks it down into amino acids. And the amino acids are then broken down into a substance called glutaric acid, which is converted into energy. And so with this energy we can talk, we can walk, and we can think. Remember, without amino acids we are even unable to think something. Okay, next, heterocyclic. In the light of chemistry, if we want to discuss what L-Histidine is, it is basically a heterocyclic amino acid. As the word itself indicates, its meaning, hetero means different and cyclic means ring. So heterocyclic means an organic compound that has a ring structure, but the condition is which contain at least one atom other than the carbon atom. Carbon atoms are usually present in organic compounds, but the condition of heterocyclic compounds are there must be one heteroatom. So in the case of L-Histidine, the heteroatom will be the nitrogen. The R group of histidine is known as the imidazole ring. Now you have to first look about the general formula of amino acids. This is the general formula of amino acids in which the two functional groups, this structure remains same in all the amino acids, which contains a carboxylate function group and a nitro functional group. The difference only comes in this point, like if we say that the main thing which is used to distinguish the amino acids from each other is this R or alkyl group. In the case of histidine, this group is imidazole. This alkyl group must be the imidazole, whose general formula or whose molecular formula is C3H4N2. Imidazole ring imparts specific properties to the L-Histidine. This is the lifeline of histidine. Either we are talking about the nature, its chemical properties, of L-Histidine all are due to this imidazole ring. Structure. Histidine is also called L-Histidine. A scientist named as Fisher says that all the amino acids occur in nature are basically the mirror images of each other. They exist in two forms, which are exactly the replica of each other. Only small differences ahead. So we can say that histidine also has two isomers or two mirrored images of each other, which are called the enantiomers. L-histidine and D-histidine are the enantiomers of histidine. If we want to distinguish the L-histidine from the D-histidine, we have to look about the position of the nitro group. If it is to the right side of the functional group or to the right side in the histidine, it will be in L-histidine or levorotatory histidine. And if the nitro group is on the left side of the histidine, it will be the D-histidine or dextrorotatory histidine. Talking about the IUPAC or the structure, the basic structure of histidine, we can easily memorize its structure by remembering its name, like 2-amino 3,1-H imidazole 5-allyl propanoic acid. Look at this structure carefully. It is basically the propanoic acid. Propanoic means 3-carbon compound. You must are familiar with the organic compounds, methane, ethane, propane, the 3-carbon compound. So let's name it according to its IUPAC name. According to reactivity order, the carboxylic group is more reactive than the nitro group, so it is positioned first, then the nitro group, and then the alkyl group. This whole structure is the alkyl group, which is called the imidazole ring. So 1 carboxyl group, 2 nitro. The substituent nitro group is at the position number 2, so it is assigned position number 2. The alkyl group is at the number 3, so it is assigned the position number 3, and it is propanoic acid, the 3-carbon acid. Physical properties. Histidine is commonly solid in the form of white crystals. Just look at the bottle. A beautiful bottle enclosing a white crystal histidine. Shape. It is in the form of needles and plates. Smell. Unlike other amino acids which are tasteless and some are bitter in taste, L-histidine is very sweet and it is odorless. Polarity. L-histidine is a polar amino acid. This is very important concept in the physical properties of L-histidine, what is meant by polar amino acid. It has a very important role in hydrogen bonding. Polar means an amino acid having oxygen and nitrogen in the side chain. As you all know that histidine has a nitrogen in its side chain in the imidazole ring. So histidine, by virtue of having nitrogen in the side chain called imidazole ring, can participate in the polar interactions which are called the hydrogen bonding. Hydrogen bonding is very important for non-polar interactions in proteins, which hold the protein chains or protein structure folded together to sustain the protein structure. So this physical property of histidine is very important. Melting point. It melts at 287 degrees Celsius. Solubility. It is easily soluble in water, slightly soluble in primary alcohols like ethanol. Primary alcohols are those in which the carbon atom is attached only to a single carbon atom, but insoluble in organic solvents like ether and benzene. Chemical properties. L-histidine is basic in nature. It is a basic amino acid. Basic means a positively charged amino acid. Now, before talking about positive charge, we should know the concept of the zwitterine. We all know that in isomerism, when have read the process of tautomerism, in which there is a shifting of proton from one functional group to the other functional group within the same molecule. So in the case of zwitterion, the carboxyl group donates its proton and the amino group receives the proton. So it becomes the zwitterion. The zwitterion is amphoteric. It means that it acts as a base in the presence of acid and acts as an acid in the presence of base. Like L-histidine is a conjugate base of L-histidium and a conjugate acid of L-histidinate ion. I have discussed earlier that imidazole has very important role in the whole structure of, it is a lifeline of the histidine. So L-histidine, which is the source of much of the biochemical activity of our body. This location is a catalytic site for certain enzyme and is also used to synthesize the metalloproteins. Its pK value is 6.1 and hence histidine is responsible for the maximum buffering action due to imidazole. So imidazole imparts specific properties to it. Other chemical properties of histidine are that its molecular weight is 155.15. It can donate 3 hydrogen bonds, hydrogen bond donor. It can accept 4 hydrogens. Its polar area is 92. Chemical reactions. The chemical reactions of histidine. The chemical reactions of amino acids are basically due to its nitro group or due to its carboxyl group COH. So the first reaction is due to the COH group, in which the histidine reacts with a base OH negative and release a water molecule. As you can see, the red indicator here, that the carboxyl group reacts with the base and it releases the water. Number 2, acid dissociation reaction. This dissociation reaction is basically the deprotonation, means the removal of hydrogen ion. It shows that histidine can occur in many forms. Like you can see that the first hydrogen ion, H plus ion, is released from this OH group. Then it becomes O negative, and then the second hydrogen. You first know that there is the positive charge here, and there is hydrogen here. There are 3 basic hydrogens. So it is H3 HI histidine 2+. When one hydrogen is removed from OH, it becomes H2 histidine plus. And now this hydrogen is removed from there. Here it is. It is removed, so it will be a nitrogen. So it becomes single H plus histidine. The third hydrogen will be removed from gas. From where? From here. The third hydrogen will be removed from here, so it becomes the histidine negative. Reactions of histidine. This is very important histidine reaction. It is called decarboxylation of histidine. Decarboxylation means the removal of carboxyl group and the release of carbon dioxide. So it is again due to the carboxyl group. This reaction is again. So histidine, in the presence of an histidine decarboxylase enzyme, converted into the histamine, and the carbon dioxide is released. This histamine has very important role in our body. It is basically a neurotransmitter, a chemical messenger. It is found in our skin, in our lungs, in our mucosa, etc. Now, its processes in our body. It is a mediator of allergic response. Like release histamines when the allergy is mast cells are present in our body, which release histamines when the allergy is encountered. Vasodilation. The histamine play role in vasodilation. Vaso means blood vessel, and dilation means the swelling or the widening of a vessel. So as you can see here that there is a blood vessel, a normal blood vessel, and there is the narrowing or there is a widening or the swelling of the blood vessel. What is the function of vasodilation? It basically increases the blood flow and it cools down our body and reduces heat loss through the skin. Once the body's temperature has turned to normal, the function is this: bronchoconstriction. Bronchoconstriction means the narrowing or the thinning of the bronchioles, the airways of the lungs, the bronchioles. As you can see that there is a normal bronchiole which is very wider, and there is the squeezing or the small narrowing of the bronchiole. It is an effective component of airway defense, protecting the lungs and rest of the body against the inhaled irritants, for example smoke, etc. But in other contexts, it can also cause difficulty in breathing, like the problem of asthma, in which the bronchus contract and restrict the air into the in and out of the lungs. Histidine receptors. We all know that histidine is present in our body. Now its location will be, there are 4 types of receptors which are present in different parts of our body. Like H1 receptor is present in brain, in respiratory, epithelium, endothelium and smooth muscles. Their function is the bronchoconstriction, as I have discussed earlier, vasodilation and wakefulness in the brain. Next, H2 receptors are present in the gastric parietal cells, brain and heart, and they stimulate parietal cells to produce hydrochloric acid and vasodilation. H3 receptors are present in neurons, and they are basically activation promotes the sleeping. Immune cells, H4 receptors are present in the immune cells, mast cells, intestinal epithelial cells, sensory neurons and cancer cells. Induces these H4 receptors present in these cells, their function is the chemotaxis. Now what is chemotaxis? Chemotaxis is basically the directed migration of a cell in response to a chemical stimulus such as growth factor. Its function is to play important role in wound healing. Moreover, the immune cells use chemotaxis for migration. Next, degranulation of mast cells. Degranulation, it is a cellular process in which a cytoplasmic granules within the certain cells secrete their contents, often outside the cell. It is an important response to an allergy. When you come across allergy, the response is called the degranulation process activators. Now we have missed the point that in skin, what does histidine do? In skin, when the histamine produced by histidine is active, we feel itching, we get rashes sometimes, and unfortunately, we have to deal with the pimples at times. Until the histidine level is normal, we have to bear the pimples, the most irritating thing. Okay, the functions of L-Histidine. Histidine basically maintain the normal level of hemoglobin. Hemoglobin, as you all know, that the protein which is the main protein for delivering the oxygen. So it plays very important role in the hemoglobin. Urocanic acid. It is basically an acid produced through the histidine, which is the main absorber of UV radiations. If we don't have histidine, we don't have urocanic acid, so we can be like this. So histidine protects skin cells from the damage, and it protects our skin. It protects our beautiful skin against the dangerous UV radiations. Additionally, it is converted to histamine. As I told you earlier, that histamine is very important messenger. Moving ahead, it is important major component of carnosine. Carnosine is an important antioxidant that slows the progression of multiple degenerative diseases, which involves a plaque buildup. Plaque. It is basically the hardening of the artery, occur when the fat or cholesterol and other substances build up in the walls of the arteries. Like you can see the picture here that there is a normal artery with no block, and when the block like this comes, it can reduce the blood flow and it may cause the blood clot, which may cause later on the heart attack, stroke, and even death. We talk about that histidine is essential amino acid that we get it through our diet. So the sources of histidine are animal proteins such as meat and dairy products are the good main sources of histidine. Next, light sources will be the rice, rye, wheat, cereal grains, and more sources will be the seafood, buckwheat. Buckwheat are basically the sea grains, like you can see here. Bamboo shoots. These are basically the shrubs or roots which are used in the Asian dishes. Cantaloupe, it is a species like a melon. So by having all these in our diet, we can easily meet our daily histidine needs. Disorders of histidine. We can talk about the disorders of histidine. Histidine. Here histidine is converted into urocanate through a histidase enzyme. As you all know that urocanic acid protects us from the UV radiations. So histidine, by the help of histidase enzyme present in the liver and kidney, is converted into urocanate. If there is a deficiency of histidase enzyme, it can cause accumulation of histidine in blood, and we can come across a condition known as histidemia. It is very dangerous because there is no treatment of this disease available. Next, the urocanate with the help of urocanase enzyme is converted into the 4-imidazole 4-propanoate. If there is a deficiency of urocanase enzyme, it can cause accumulation of again histidine in blood and a condition called aciduria. Its condition treatment is also not available. Disorders of histidine. Glutaric aciduria. It is basically a condition in which the amino acids are built up in our body, which can cause the harmful effect to our body. Like in this, the babies are unable to make the amino acid like histidine, and they accumulate at a very dangerous level, and they can cause the fluffiness, weakness in our muscles, which is a condition known as hypotonia, and it can also cause bleeding around their brain like subdural hematoma. Its treatment is very simple, that high protein foods need to be limited, which contains a high level of histidine like meat, fish, cheese, etc. A tablet called L-Carnitine is also used to cure this type of a disease. Now, the chronic kidney disease. Before going to it, I would like to give you the concept of anemia. Anemia is basically due to the lack of red blood cells, and obviously the red blood cells are the source of the histidine. Our histidine is the source of the red blood cells. So anemia is due to the deficiency of red blood cells or due to the deficiency of histidine. Anemia, this disease is very common in patients with chronic kidney disease. Kidney disease, loss of kidney function, we can say. So its symptom will be the nausea, vomiting, loss of appetite, urinating more or less, decreased mental sharpness. You can see here that there is a normal kidney with the glomerulus, ball of capillaries collecting tubules, and here the damaged kidney with damaged glomerulus and damaged tubules. How can we cure this disease? We can cure it by controlling our blood pressure, meet our blood glucose. If you have diabetes, work with your healthcare team to monitor your kidney health. Take medicines as prescribed. Work with a dietitian. Make physical activity part of your routine and aim for a healthy weight. Cautions. Histidine is possibly safe for most people. For example, the research has shown that the doses up to 4 grams per day are noticeable, have not caused any side effect. But taking too much histidine may cause psychological issues and it may lead to the mood disorders. Mood disorders are basically the disturbance of our emotional state, like the most common is the depression. Women who are pregnant should not use histidine supplements. It can cause serious problems. Folic acid deficiency. If anyone have this condition, he is not prescribed to use the histidine because it can cause an unwanted chemical called formimoglymatic acid to build up in the body, which can cause the serious side effects. Applications. In police detection test for histidine, the diazonium salt formed couples with imidazole of histidine in alkaline medium to give a red colored chromogen azodie. Basically, the police test is used to identify the histidine, and during this test, a dye called azodie is formed, which has very important applications in our daily life. Like it is used in the pharmaceutical industry. This red dye can be used in the pharmaceutical industry, cosmetics, and the textiles. Here, these dyes can be used in the textiles, leather articles, and also in some foods. Going towards the conclusion, histidine is classified as a nutritionally essential amino acid because we have to take it through our diet. Overall, it has been demonstrated that histidine is important for human health, but excess histidine has biochemical and physiological side effects. Like it can make our kidneys work harder and it may cause growth problems if a single amino acid supplement is taken. So there are limited data regarding the benefits and the adverse effects of histidine. Histidine up to 4 grams per day, up to 12 weeks are just advised. I have also added some references to it in case you guys want to visit for further information. Okay, time for questions. If you guys have any query about the topic, you are free to ask. I advise you to ask at least one question because questioning enhances the critical thinking. So you guys must question. Okay, the journey comes to an end. Thank you so much for your precious time. Now I would like to say goodbye. Till then, take a very good care of your histidine and keep chemistry with a smile. Have a nice day. Allah Hafiz.